Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about section of solids. I am Dr. AIP Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the today's discussion will be about a solid which is being cut by a section plane which happens to be inclined to the horizontal plane and perpendicular to the vertical plane. So such cutting planes, they are called AIP. That is AIP, it is a plane or a cutting plane which happens to be inclined to the horizontal plane, and this cutting plane is perpendicular to the vertical plane. So if any solid, it is cut by an AIP, that is cutting plane happens to be inclined to HP and perpendicular to VP, so this upper portion of the solid, this will be discarded out, and the remainder portion of the solid, this is the one which will be left with us. So this is the cut surface. You see, this is the section surface in which we are interested that we want to obtain the true shape of the cut section over here. But when we look at this particular cut surface or the cut solid in the front view, the edge view of this cut surface will be available in the front view. Now if we look at this particular solid, section solid from the top, then in the top view we are only able to obtain the apparent shape corresponding to this cut surface or the section surface. The reason is, since this surface happens to be inclined to HP at a certain angle, so the projections of this surface onto the horizontal plane which are obtained in the top view, they will provide us only with the shortened view, or they will provide us with the apparent view of this cut section. So the section top view is insufficient to provide us the true details of this cut surface. So if we are required to obtain the true shape of this cut surface, then what we have to do? We have to draw another additional auxiliary inclined plane which will be parallel to this cut section or the cutting plane, and then the projections drawn through this particular section surface onto this new AIP, that is the auxiliary plane projections, they will be able to provide us with the true shape of the cut section. So let us work out the problem for today. So here today we have got a cube which happens to be inclined to the vertical plane, and this cube has been cut by an AIP which is inclined to the horizontal plane and it is perpendicular to the vertical plane. Now usually whenever an AIP is going to cut any given cube over here, usually it will be cutting all the four vertical, you see, projectors over here. These are all vertical projectors or the corresponding to the height, right? So this is usually the longer edge. So since this is the cube, so this edge is not longer because all the dimensions, they are equal, right? So this is, we are now going to term it as a vertical edge. So 4D, 1A, 3C and 2B, they are the vertical edges. So usually our cutting plane passes through all the vertical edges, and the number of points of intersection which are usually obtained, they will be 4. But this is a special case in which our cutting plane does not pass through two vertical edges. Which are those vertical edges? This is one vertical edge, 2B, and this is another vertical edge which is 4D. So our cutting plane does not pass through these two vertical edges. Instead, it passes through the top face of this cube, and it also passes through the base of this particular cube. So as this cutting plane cuts the top face of the cube, so you see, rather than cutting one vertical edge, now this cutting plane intersects with two of the edges of this particular cube on the top face. So the edge 3, 4 will be cut at the point number 14, and the edge 1, 4 is being cut by this cutting plane at point number 15. Similarly, since this cube is also passing through the base, so the edge AB has been cut by this cutting plane at point number 11, and similarly the edge BC of the base, it has also been cut by this particular cutting plane at point number 12. So here you see points 11 and 12, they are obtained on the base. 13 point, it is obtained on this vertical edge 3C, and then 14 and 15, these two POIs or the points of intersections, they have been obtained at the top face corresponding to these two edges. And finally, sixth point, it is obtained by virtue of cutting off this edge, vertical edge 1A by the cutting plane. So here, instead of getting 4 POIs, so we are going to get 6 points of intersection over here. So this is a special case, and we had discussed this thing in the previous lectures as well, that maximum number of points of intersection in case of any prism or cube can be n plus 2. So the maximum number of edges over here in this case of the base, they are 4. So n plus 2 means 6 cutting points of intersections have been obtained in this particular case. So here you see, here we have the XY line, and we have drawn the top view of this inclined cube over there, which is resting on its base on the ground. So the bottom points, they have been labeled as ABCD, and the top points, they have been labeled as 1, 2, 3, 4. So this cube is inclined at an angle of 40 degree with respect to the vertical plane. So we can say that one of the edge or one of the face of the cube is inclined at an angle of 40 degree with respect to the vertical plane. And in this case, you see, in the front view, these are the projections, and this cutting plane, it bisects the axis, that is, this is the 40 millimeter, so the midpoint will be 20 millimeter. So it passes through the axis 20 millimeter above the base, and it cuts this solid at an angle of 45 degree to the horizontal plane. So we can say that this AIP is inclined at an angle of 45 degree with respect to the HP. Now you see, since 6 points have been obtained, as I have already explained to you, so these 6 points in front view, they are available in the form of edge view. If we are going to look at this section solid from the top, we are going to obtain this sectioned portion, which will be the apparent shape. So this is the section top view, which is being obtained in the top view. But since this surface was inclined with respect to HP, so its projection on HP, they provide us with the shortened view or the apparent view of the surface. So what we have done to obtain the true shape, we have drawn another AIP, that is X1, Y1, which is parallel to this cutting plane, and then projections through all these points, 6 points over here onto this AIP, they will provide us the auxiliary plan projections over there. So this auxiliary plan projections which are obtained over here, they are going to provide us with the true shape of this cut section, right? So this was the basics or the methodology which will be followed. So let us work out the projections, but first of all, read out the statement of the problem over there. So here we have the problem, that is, the cube has an edge 40 millimeter. It is lying with one face on the horizontal plane, and one of the edges is inclined at an angle of 40 degree to the vertical plane. And this cube is cut by a cutting plane bisecting the axis at an angle of 45 degree to the horizontal plane. So the angle of inclination of this cutting plane will be 45 degree with respect to the horizontal plane, and this is perpendicular to the vertical plane. So we are required to draw the sectional top view and the true shape of this section. Now let us start working with the basics. So first of all, we are going to assume that this cube is not inclined with respect to the vertical plane. So we are going to draw two edges which are perpendicular to the vertical plane. This is the starting point. So this is the top view, that is 2B, 1A, 4D and 3C, they are the vertical edges, and then ABCD, they were the points of the base. So we have got B dash, C dash and A dash, D dash as the projections of the base in the front view. Similarly 2 dash, 3 dash and 1 dash, 4 dash. So these are the projections of the top face of this particular cube over there, and the height is 40 millimeters. So only once we have labeled, because height, all the dimensions, they are equal to 40 millimeter in case of the cube. Now we have to rotate one of the edges. Please check, one of the edges of this cube will be rotated at an angle of 40 degree. So once we rotate it, let us once again mark the points. So A1, 2B, 3C, 4D, they are the vertical edges. Now we have found or worked out the axis point for this particular cube. So having worked out the axis point, now we need to draw the front view as well. So we have drawn projectors through all these points. So axis height will again be 40 millimeter. So we can draw this projector over there. So we will be getting 40 millimeter height straight away, right? So once again, let us mark these points. On the bottom, it will be A dash, B dash, C dash, D dash. Similarly, 1 dash, 2 dash, 3 dash, 4 dash will be there at the top. But there is one thing we need to observe. Since the observer is going to look at the solid from this side, you see, observer is going to look at this object from this side. So these three vertical edges, observer will be able to see very clearly. That is 2B, 1A, 4D. But 3C, it is the vertical edge which is farthest away from the user and it is nearest to the XY reference line. So 3 dash and C dash, they will be joined with the help of a hidden line or the dotted line. So rest all the vertical projectors, they will be dark. So let us do the marking. This was 2B. So this is B dash and this is 2 dash. This is 3 and C. So this is C dash and this is your 3 dash. Similarly, this is 1 and A. So 1 is the uppermost point, A is the bottom point. So 1 dash is the top point of the face and A dash is the bottom point regarding to the base. Similarly, 4 and D was lying over here. You take the projector upward. So D dash is the projector of the base in the front view and 4 dash is the projector point for the front view corresponding to the corner 4 of this cube. Now, only thing we need to remember, C dash, 3 dash has to be dotted. Rest everything will be dark, right? So we haven't drawn anything with darkened line because right now we don't know which portion of the solid will be cut. So all whichever lines they are drawn solid, we assume that they are drawn with the darker line over here. So now let us apply the cutting plane at this particular position. So this we are going to pick up in the next slide. So once again, the solid has been inclined, axis has been evaluated, and the base points and the top points, they have been marked onto the front view. So this is the top view of this inclined cube. Front view of this inclined cube, and this happens to be top view of this inclined cube. Now next is we have to mark the position of the cutting plane. So the cutting plane is going to bisect this axis. So we have marked 20 millimeter. So this distance will give me the point of intersection of the cutting plane with respect to the axis of this particular cube. So this is the axis of the cube. So since it is going to bisect the axis, so I have marked 20 millimeter. So I have obtained the point of intersection of this cutting plane with the axis of this inclined cube. Now having worked out this, you see, auxiliary inclined plane, that is this cutting plane over here, which is inclined at an angle of 45 degree with respect to the horizontal plane. Now let us work out the points of intersection. We'll be starting from the base. So you see, this cutting plane has intersected the base of this particular cube, and base means once I draw this vertical line, please check, this is the remainder portion of the solid. So that's why we have darkened it, and this portion of the solid has been discarded. This portion has been cut out and this will be thrown out or this will be discarded. Now let us work out the projections of the points of intersections in the top view. So this is the, please check, this is the point of intersection of the cutting plane with two base edges. What are those base edges? You see, one base edge is AB, another base edge is BC. One base edge which has been cut, it is AB. AB edge has been cut at this point and BC base edge has been cut at this point. So 2 points I am going to name them as 11 and 12 because I am going to move in clockwise direction. So the first point I am going to start from here. This will be 11, this will be 12, and then 2 points on the top will be in the front view. They will be 11 dash and 12 dash. So which point is 11 dash? Please check. 11 dash, it is the point of intersection of this cutting plane with the base edge AB. So this is the point of intersection of this cutting plane with the base edge AB. You see, with the AB, that is why I am going to mark point 11 over here. Similarly, what is the name of point 12 dash? So point 12 dash, it is the point of intersection of this cutting plane with the base edge BC. So in the front view, you see AB lies here. This is A dash, B dash. So basically we can say that 11 dash, it is the point of intersection of the cutting plane with the edge A dash, B dash in the front view, and 12 dash, it is the point of intersection of this cutting plane with the front view of the base edge B dash, C dash. So once you bring both of these points down, so we draw the vertical projector through 11 dash and 12 dash. So point 11 will be lying on the base edge AB and point 12 will be lying on the base edge BC over there. So just see, 11 number point has been evaluated, 12 number point has been evaluated. Now we are going to move in clockwise direction. So if we are moving in clockwise, next point which will be encountered is this one, because our cutting plane is also cutting this vertical edge of this cube, which happens to be 3 dash C dash. So we will say that if this is 11, this is 12, so this cutting point name will be 13 over here. So I will now put down 13 dash over here. So please see, 13 dash, it is the point of intersection of the vertical edge of the cube, which happens to be 3 dash C dash. It is there in the front view. Now if I bring this point down, please see, if I bring this point down from 13 dash, so wherever it intersects with this vertical, you see, projector of 3C, it is a point view basically, because this vertical projector, you see, this vertical edge, this is perpendicular to the horizontal plane. So even if a one more point is located on this perpendicular, so this is nothing but a straight line. So any number of points which are going to lie on this line, they will appear to be a point in the top view. So therefore 3 dash, 13 dash and C dash, they will all have one point of projection. That is, this line will be converted into a point view. So this is my point view for 3, C and 13. So my 13 point has been located at this corner of the base over there. Next you see, I am moving this way. So my next point which will be encountered over here, it will be, it is not cutting 4. You see, D and 4 is not being cut by this cutting plane. So as I am moving like this, so this point is not to be considered because this edge has not been cut by the cutting plane. So as I am moving in clockwise direction, now my next point of intersection, you can see, it is over here. This is not being cut, but the top face has been cut over here. So this top face, I will bring a vertical projector from here. Just see, this is a vertical projector from top face. Now I will be able to find out which edges of the top face it is going to cut. So now my cutting plane, you see, I am moving from here. So the first point encountered will be this one. This will be point number 14. And where does this point number 14 lie? It lies on the front view of the edge, which is 3, 4. That is, point number 14 will lie on the front view of 3, 4, means it will be cutting the edge 3 dash, 4 dash in the front view. You see, edge 3 dash, 4 dash, because you see, I am going to encounter this point first. So name of this point will be 14. So 14 means 14 dash is going to cut the front view of the edge 3 dash, 4 dash over here. Next, you bring 14 dash point down. So wherever it intersects the top view of 3, 4 top face edge, I get the point 14 over here. Similarly, 15 number point, so it lies here. It means that my cutting plane has cut this edge 1, 4 in the top view. So in the front view, the edge which will be cut will be 1 dash, 4 dash. So we can say that POI 15 dash, it is obtained by virtue of intersection of this cutting plane with the front view edge that is edge of the top face, which is 1 dash and 4 dash over there. So this 15 dash, you see, I am going to bring down the top view projector. Now I am going to evaluate. So wherever this 15 dash point meets the top face edge 1 4, so I get the point 15 over here. So this way you see 11, 12, 13, 14, 15. So this is not to be considered because this vertical edge has not been cut over there. I move further. This now, this is 1A. Just see 1A is there and this 1 dash A dash has also been cut. So this point name will be 16 because I am moving in a particular order. So this point's name will be 16 dash. Just see, name of this point is 16 dash. So we can say that point 16 dash, that is point of intersection, POI 16 dash, it is the point of intersection of the cutting plane. This is the cutting plane with the vertical edge 1 dash and A dash in the front view. So this POI has been obtained, 6th POI has been obtained in the front view. Now I'll bring this down. As I bring this down, once again you can see A, 1 and 16, they will all lie on this corner of the top face over there. Reason? Because 1 dash, 16 dash and A dash, they lie on one vertical line and which is perpendicular to the horizontal plane or the XY line. If you are going to look at the top view of all these 3 points, they are going to coincide with each other. So this way 11, 12, 13, 14, 15, 16, 6 POIs in the top view have been located. 11 dash, 12 dash, 13 dash, 14 dash, 15 dash and 16 dash. 6 POIs have been located in the front view. So obviously in the front view, the cut surface will appear to us as an edge view. Whereas in the top view, we are going to get the section top view. And this section top view happens to be an apparent shape. It will give us the reduced shape, shortened shape corresponding to this cut section. Why? Because this cut section happens to be inclined to the horizontal plane. So the projection of this cut section on the horizontal plane will give us the shortened view or the apparent view. So we can name that this view is section top view. And please see why I have joined this. Please check why I have joined this, because this is the uncut portion of the solid. So this is the uncut, that is why this has not been shaded. The uncut portion of the solid has not been shaded, whereas this portion I did not join. Why? Because this portion has been thrown out. You see, this is the portion which was cut and this is no longer available with us. So something which is no longer available, this will be drawn with a lighter color over here. So this is my shaded portion corresponding to the cut section, top view or the apparent shape. This is the uncut portion of the solid. Now we have obtained the section top view, which is the apparent shape. Now I want to obtain the true shape of this cut section. So how that can be done? I am going to draw another auxiliary inclined plane parallel to this cutting plane or this cut section over here. So you see, now we are going to look from this side. As we are going to look from this side, we will assume that this solid is transparent, right? Whereas this shape you can assume to be opaque. So cut surface you can assume to be opaque, whereas the solid will be your transparent solid. Now we are going to draw projectors through these 6 points. You see 11 dash, 12 dash, they are falling at one point. 13 dash and 16 dash, they are unique points. And then 14 dash and 15 dash, they are also coinciding with each other. So 4 projector lines we are going to get, and we will be obtaining 6 POIs in the top view over here. So please see x1, y1, it is an AIP which has been drawn parallel to this cutting plane. So let us draw the projectors through all these 4 positions over here, but these refer to 6 points over there. So 6 POIs they are being referred to, which are available in the front view. So which distances we are going to mark over here? So the view which we are trying to obtain on the AIP, this will be called auxiliary plan. So the name of this view is auxiliary plan. So in order to draw the auxiliary plan, so the distance of all the points of intersection from the XY reference line will be measured and they will be transferred over here. So please see, I am going to transfer the distance of point 11. Just see, this is the distance of point 11, which is the point available to POI available to me in the plan or the top view. So I am going to measure this distance from the XY reference line. I'll mark this distance over here. So name of this point happens to be 11,1. Similarly, 12 point. It is lying on the same locus line, but the distance is slightly shorter. So I'll be measuring this distance now, and this distance has also been transferred in front of this AIP over here, right? So name of this point is 12,1. So I am transferring the distance of point 12, POI 12 from the XY reference line. So point 12,1 has been obtained. Next POI is 13. So corresponding to 13, just see, this is the distance of the point POI 13 from the XY reference line. So on the locus line of 13 dash, I am going to mark this distance over here. So name of this point 13,1. Next, I have got next point, which is 14. So just check this out. Distance of POI 14 in plan as observed from the XY reference line is this. So I have transferred this distance onto the locus line, which is emerging from 14 dash. Similarly 15. So distance of 15 is slightly larger than this. It lies on the same locus line. So 15 dash also lies on the same locus line. So I am going to plot this point over here. 15,1. Last point 16. So I am going to measure the distance of this point 16 in the plan view from the XY reference line. So this is my POI 16. So corresponding to the locus line or the projector through 16 dash, now same distance will be marked over here. So this is the distance of point 16 which has been marked. So point 16,1 has been obtained. So just see, all the 6 POIs, they have been located appropriately in the auxiliary plan, which is drawn on the AIP, which happens to be parallel to this cutting plane. So let us join all these edges over here. So this is the true shape of the cut section. So sectioning has been done at an angle of 45 degree with respect to X1, Y1 reference line, right? So this is our true shape or the auxiliary plan. So this way, you see, using the principles of projections of solid, sections of solid, and the auxiliary plane method, we have been able to obtain the front view of the section solid, the top view of the section solid, and the true shape of the cut section over there, right? So this is all about the discussion regarding the sectioning of a cube which is inclined with respect to VP using an auxiliary inclined plane. And since this is a special case, so we are going to get n+2 number of POIs in this particular case. So we'll be continuing with this in the future lecture. Thank you very much. Thanks a lot. Thank you very much.